Hello, honors physics students. Alright, so as we continue studying the different properties of waves as they pertain to light, let's finish up by talking about diffraction and interference, the only properties we really haven't talked about yet. Remember, diffraction is passing through an opening and spreading out, and then when that happens, the waves overlap and interfere with each other. Sometimes constructively, in this case with light, that would make it brighter. Other times destructively, in terms of light, that would make it darker. This is how we first proved light was a wave, by sending light through a double slit, two openings, and the overlapping patterns made a repeating pattern of bright, dark, bright, dark, bright, dark. That translates to constructive, destructive, over and over. Okay, so here's a photograph of a demonstration I would do in class. Here's our polychromatic source of light, or white light, shining onto a white piece of paper. And then I'm going to put in front of it what's called a diffraction grating. Diffraction grating is a little slide, a piece of plastic, into which there's been cut many, many openings, really on about 1,000, if not more, openings for light to go through. So here's what that looks like. This over here is the diffraction grating in front of the white light. And look what happens. We get the color spectrum showing up on the other side. Down the middle, it's still white. Now, it's a little bit tough to see, especially with the photograph, but the white light is a little bit dimmer than it was before. If you saw this in real life, you'd see it's significantly dimmer. Why is it dimmer? Well, some of the light goes off to the side. Light is just energy, right? So there's less light to go down the middle, and so it's just not as bright, but it's still white light. But there is a repeating pattern. If you actually look really closely, you should see the color spectrum is over here as well, and is over here as well. And so it's bright, dark, bright, dark, bright, down the middle, dark, bright, dark, bright. It's that repeating pattern that's indicative of an interference pattern. Which color diffracts the most? Well, diffraction is going away from center. So you can see clearly the red color diffracts the most away from center. The violet diffracts the least. If you were to go back to our notes page that has the color spectrum on it, the whole electromagnetic spectrum, and you see the colors of the visible wavelengths split up, you see that red has the largest wavelengths. And so here we see that the larger wavelengths diffract away from center more, the smaller wavelengths diffract to smaller angles. So in our notes, this is what we would draw. I got a little bit tired of using the drawing tools on PowerPoint, so this is just exactly what would be on our board. First, that the amount of diffraction depends on wavelength, and that's really all we're going to do with this. We're not going to get into the equations, because the equations actually get quite complicated very quickly. It's really beyond the scope of what we do here in honors physics. And here's what a picture might look like. A diffraction grating is really just a whole bunch of openings, so we show it here by a whole bunch of obstacles in the way. Here's our polychromatic white light source. Down the middle, like we just saw before, is still white. And then here's the color spectrum going off to the side, with the red diffracting to the largest angles because it has the largest wavelengths, the violet diffracting to the smaller angles because it has the smaller wavelengths, and of course all the other colors are in between.